Previously, we learned that the cosecant of theta is the inverse of the sine of theta. And if that's true, then the cosecant of theta equals 1 over the sine of theta. Similarly, the secant of theta, which is the inverse of the cosine of theta, is equal to 1 over the cosine of theta. And the cotangent of theta, which is the inverse of the tangent of theta, is equal to 1 over the tangent of theta. Since the first row of functions is the inverse of the second row of functions, and vice versa, the second row of function is the inverse of the first row of functions, then given a function, we can find its inverse. So for example, if we were given the cosecant of theta, we could find its inverse, the sine of theta, simply by taking the inverse of the cosecant of theta. For example, if we wrote 1 over the cosecant of theta, that would give us secant of theta. Similarly, if we were given the secant of theta, and we took its inverse, 1 over the secant of theta, the answer would be the cosine of theta. And with the tangent, if we were given the cotangent of theta, wrote its inverse, the result would be the tangent of theta. Now we could do the same with the second row of functions. If we were given the sine of theta and took its inverse, 1 over the sine of theta, the result would be the cosecant of theta. If we were given the cosine of theta, we took its inverse, 1 over the cosine of theta, the result would be the secant of theta. And lastly, if we were given the tangent of theta, took its inverse, 1 over the tangent of theta, we would get the cotangent of theta. Let's look at why the first row of functions works mathematically. We'll look at the first one, sine of theta equals 1 over the cosine of theta. If we were to write out sine of theta equals 1 over the cosecant of theta, and since we know that the cosecant of theta equals 1 over the sine of theta, we can rewrite that in the denominator here. Cosecant of theta equals 1 over sine of theta. Now we're dividing by a fraction, so we're going to multiply by the inverse of the denominator. So we'll take the numerator 1 times the inverse of the denominator, sine of theta over 1, and the result is the sine of theta. Therefore, we've shown that 1 over the cosecant of theta equals the sine of theta. We could do a similar analysis for the two remaining functions, cosine of theta equals 1 over the secant of theta, and tangent of theta equals 1 over the cotangent of theta. Let's look at the two functions in the third row. We've got the tangent of theta equals the sine of theta over the cosine of theta. Let's see why that's true. The tangent of theta equals opposite over adjacent. We've already learned that. And we know that the opposite side equals y and the adjacent side equals x. And we've also learned that the sine of theta equals y. Therefore, we can substitute sine of theta, and we've learned that the cosine of theta equals x. So we can substitute the cosine of theta. Therefore, the tangent of theta equals the sine of theta over the cosine of theta. The cotangent of theta, which is simply the inverse of the tangent of theta, we could just flip the fraction. Instead of sine of theta over cosine of theta, we're going to flip that and we'll have cosine of theta over sine of theta. We could do a similar analysis as we just did with tangent of theta as well, showing that cotangent of theta equals adjacent over opposite. The four functions in blue, cosecant of theta, secant of theta, tangent of theta, and cotangent of theta, are particularly helpful for determining quadrant angles. We've already previously learned in the quadrant angles 0 degrees, 90 degrees, 180 degrees, and 270 degrees, how to find the cosine and sine of each of those angles. So therefore, if we were able to rewrite the remaining four trigonometric functions, cosecant of theta, secant of theta, tangent of theta, and cotangent of theta, in terms of sine and cosine, then we would be able to find those functions easily as well. So we've done just that. Cosecant of theta equals 1 over the sine of theta, secant of theta equals 1 over the cosine of theta, tangent of theta equals sine over cosine, and cotangent of theta equals cosine over sine. Again, notice that all four of those functions have been rewritten in terms of cosine and sine. I recommend pausing the video now and becoming more familiar with these functions before moving on. We'll now use the trig identities we just learned in the next few slides to evaluate trigonometric functions of the quadrant angles. So in this slide, we're going to be looking at when theta equals pi. So let's draw a picture to help us visualize this. So when theta equals pi, this is our unit circle here with a radius of 1, and the coordinate at pi, or coordinates, is -1, 0. So therefore, the sine of theta equals what? It equals 0, the y-coordinate. Similarly, the cosine of pi equals -1, the x-coordinate. The tangent of pi, which we just learned, is the sine of pi over the cosine of pi using our trig identities. And since the sine of pi equals 0 and the cosine of pi equals -1, then 0 over -1 is 0. Now the cosecant is 1 over the sine of pi, another trig identity we just learned. But the sine of pi is 0. But anything divided by 0 is undefined. So there is no trigonometric function at cosecant of pi. The secant of pi, we learned that that's equal to 1 over the cosine of theta, or 1 over the cosine of pi in this case. So that's 1 over the cosine of pi, again, is -1. 1 over -1 is -1. And finally, the cotangent of pi, again using our trig functions, is equal to the cosine of pi over the sine of pi. Cosine of pi is -1, sine of pi is 0. Anything divided by 0 is undefined, so the cotangent of pi is undefined. Let's take a look at another example. When theta equals 3 pi over 2, again, I'm going to draw a diagram to help us. Pen. 3 pi over 2 down here, which is 270 degrees. Our coordinates are 0, -1. The sine of 3 pi over 2 is the y-coordinate, where 3 pi over 2 intercepts the unit circle. That occurs at -1. The cosine of 3 pi over 2 is the x-coordinate, where 3 pi over 2 intersects the unit circle, and that occurs at 0. And the tangent of 3 pi over 2 equals, using our trig identities, the sine of 3 pi over 2 over the cosine of 3 pi over 2. Sine of 3 pi over 2 is -1, as we've already discussed, and the cosine is 0. But since we're dividing by 0, the function is undefined, so the tangent of 3 pi over 2 is undefined. Next, we have the cosecant of 3 pi over 2, which is equivalent to 1 over the sine of 3 pi over 2, which is 1 over -1, which equals -1. The secant of 3 pi over 2, which is equal to 1 over the cosine of 3 pi over 2. The cosine of 3 pi over 2 is 0. Again, we have another undefined function. Whenever something is defined by 0, divided by 0, it's undefined. And lastly, the cotangent of 3 pi over 2 is equal to the cosine of 3 pi over 2 divided by the sine of 3 pi over 2, which equals 0 over -1, or 0. Now go ahead and pause the video and try these 6 trig functions on your own. Again, we'll draw a picture to help us visualize these functions. And we're looking at where theta equals pi over 2, that's here. Pi over 2, or 90 degrees, intersects the unit circle at 0, 1. So the sine of pi over 2 is our y-coordinate, 1. The cosine of pi over 2 is our x-coordinate, 0. The tangent of pi over 2 is equal to the sine of pi over 2 over the cosine of pi over 2, which equals 1 over 0. Therefore, it's undefined. The cosecant of pi over 2 is equal to 1 over the sine of pi over 2, which equals 1 over 1, which equals 1. The secant of pi over 2 is equal to 1 over the cosine of pi over 2, which equals 1 over 0, which is undefined. And lastly, the cotangent of pi over 2 is equal to the cosine of pi over 2 over the sine of pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. Answer is 0.